Evgeny Nikol from Google. Hi, I did not want you to stop thinking completely. I even didn't start speaking, and some of you have already made some false assumptions about my presentation. Before I say this sentence, stop thinking, I would like just to take a few minutes of your afternoon sleep to think over this title. IPv6 is here. IPv6 is here. Alexei, could you please give me a hand with this remote control? Here is the slide. One very well-known company monitors the number of users checking their resources via IPv6 protocol. I would say that these numbers are quite notorious. It's a very pleasant thing to point out that in 15 years, more than 128% of the users will be using IPv6. Will shift to IPv6 and then I will retire. Mr. Gibson once said IPv6 is here, but it's just not very evenly distributed. I don't know whether you can read the slides, but the thing that you see was initially supposed to be looking like the world map. And as far as you can see, that some of the countries in Europe have more than 10% of the users shifted to IPv6, switched to IPv6, and in Russia we don't even have the three-thirds of, we don't even have a tiny bit of those people using IPv6. You don't use IPv6 here commonly. It could have been one of the reasons, by the way, getting you together and making you shift to IPv6. You do use it. I didn't know about that. They didn't inform me. They didn't tell me about that. So I eventually hope that after this presentation, someone will switch IPv6 here to make this look even more attractive. And instead of I will have more people joining us and our services, but spammers. I'm not going to speak about why we need to implement IPv6 because I'm sick and tired speaking about the need of the actual implementation. So if you're a little bit tired of these kind of presentations, you can go back to reading your emails. But instead I will speak about the inertia of thinking when people implement IPv6, like they once were asked to once again implement IPv4. So in my view, why do we have this inertia of thinking? People think that IPv6 is just a longer IPv4, but in actual fact, people who developed that protocol had done their homework and they developed a very interesting and conceptually different protocol from IPv4. I will share a few ideas about these principal differences in the following slides. I actually think that when you implement IPv6, it would be very nice to know what's the maximum use of this protocol, and you would not be cracking nuts with a microscope, as we put it in Russian. One thing I would like to address that hardly everyone knows, that IPv4 all addresses are equal and they are protocol-wise, not so much different. They cannot be unique, but they're still global addresses. With the IPv6 style, we have a very interesting document which describes the scope of the address architecture, explaining that for every IPv6 address there is a scope identified: link, local, and global. When you take a look at the address, you can say what would be the scope. Once you implement IPv6, you have link local addresses that are engaged with IPv6. Link local addresses make sense at the link, because once I saw engineers complaining that would not be able to ping the link local address. Link local address makes sense only at a link. If you don't do it, if it's just like, looking for a person in a hotel with a note, not knowing where this particular person is sitting in the hotel. Local addresses have a very interesting application scope. Take a look at the IPv4 only network. The loopbacks at switches, /31 at every link, the deficient number of address space. With the new backbones, you are likely to encounter a problem. RIPE is unlikely to provide you with lots of addresses. You are quite fortunate if you are somewhere in Africa, but if you're elsewhere, not so lucky. But if we try to implement IPv6 at this same network environment, we will see that the loopbacks at every link already have some addresses, and it's sufficient to make the entire system work. Without loopbacks, it will be even more convenient to manage this entire system. Then we'll take another step and shut down the obsolete protocol that no one needs anymore, and just have 5 addresses for 5 routers. If you manage it manually and not with the use of the automated system, it may be convenient for you. Less typos. I remember a long discussion whether we could recommend the best practices here. Not sure, it's just one of the options, and with the only principal drawback of this particular design is that when you have more than one logical interface between the routers, and the tracers will not show the whole bunch of the information that you would like to get, or alternatively SVP over IP6. If there is a need for SVP over IPv6, it's an unlikely proposal. Anyway, you'll be able just to initiate the routers with IPv6 functioning, and everything will work automatically without actually assigning anything. With the free address space, so IPv4 every address space can be, used elsewhere and justify the implementation of this new protocol. I was once a consultant to different companies, and a lot of time was spent actually discussing whether we need to have /128 or /127, or whether we would allocate /125 for this segment and then change this at a later stage. With IPv6, everything has been thought of for you. You don't need to think anymore. If it's not a point-to-point or a loopback, it's always /64 for everything, else with a few exceptions. Some internet exchanges would just like to assign /112 and other strange networks, and people then find out that their routers will not be able to work with these prefixes because the older equipment would think about 128 or 124, and everything which is in between the hardware, it's not supported on a hardware level, and you will just need to contact the hardware vendor, figure it out with them, which is not a very nice thing to do. Anyway, /64 will be enough for everything. Here is one hot topic that everyone likes to go through. In IPv4 environment, everything looks nice. You have a private network, and we establish a net. With IPv6 shift, you immediately look for the favorite private address and not being able to find them. The private space, the private address, I mean, is the thing that people would like to get. Some very inquisitive people have ULAs. They find ULAs. The addresses that are expected to be unique if you have generated the prefix properly. So everyone thinks it's just exactly like the private network, which is a bad thing to do. I was told that I only have 5 minutes, so I will skip the details anyway. There is a draft which is available in the ITF group, which documents the possible ULA uses, but the general takeaway: ULAs are not an address space. Another hot topic. Seems like that the only way to create the static address for IPv6 host is the DHCP. So immediately sysadmins start asking about the same DHCP approach for IPv6, and turns out that it does not really work. With IPv4 everything works, but with IPv6 style it's different. It may not work. The thing is that the actual support of IPv6 is not mandatory for IPv6 hosts, and there are other ways of doing so. In actual fact, the auto configuration, stateless address auto configuration, automatically generates the host ID, the 64-bit one, get all the information about routing, and thanks to our dear vendors, they have almost implemented the data transmission about DNS settings with router advertisement. Cisco have done it. And if we implement the new protocol, there is a great standpoint. The new protocol has been initiated and the vendors will bring everything to us. But they don't. You just need to go to vendors asking them to help you. That's what I recommend you to do. Like I was saying, the host may automatically get all the settings. In IPv6 environment, the standard model was involving different protocols, VRRP, HSRP, etc. We attempted to use the same approach for IPv6, but we can do without that. But if we really want, we can. In actual fact, in the protocol, there are some settings provided. If you really would like to have a few routers, all the routers send router advertisements with a lifetime. If you would like to remove the router from there, the router starts announcing router lifetime equals 0, and it's not used as a router advertiser by default. Neither for IPv4 nor for v6, if once you've got this DHCP setting, is a way to explain that it's been already expired. But if you use a router advertisement, router advertisements to be precise, you can do this job. And a very interesting feature that turned out that not everyone knows in IPv4 style. I do remember how we all started with IPv4. There were a lot of things said in the books about this subnet mask and about how we all belong to the same subnet with the use of the mask. If we are different subnets, you always need to use a router. With IPv6, we use differently. By default, the host believes that all of the addresses are somewhere beyond the router, and then this address space does not necessarily belong to the same network, but they are on link, and two of them belonging to the same segment can talk directly without using any router. I don't have too much time, so therefore, instead of explaining, I just show you some URLs that you can refer for detail, where you can refer for detail. So the easiest way is the loopback approach. And now we are using talking about dual stacking services. IPv4 style, just replicate, do IPv4 config. But if you use this style here, it would be wrong, because if you take a look how it looks for some of the services, it seems like that they leave just one line for their service. If the system thinks that there is a possibility to establish this connection, the host will first try to reach it over IPv6, and only after that they will use IPv4. So the client will just be tired of waiting before the router completes the task, and it makes people very upset. The recent research shows that there are not so many mailing services used with over IPv6. Strange, because it's a very reliable service to failures. It's very transparent for the users. But the main problem is not the network part of the protocol. It's the anti-spam function. There is an article which is very useful for those who use IPv6 connectivity for electronic mail. And the use of the dual stack of the protocols, well, it's complicated. You just need to double the settings. You need to quadruple the monitoring functions. It's too difficult. So instead, you just better use IPv6 in the kernel, and the system administrators monitor just the IPv4 network, and they don't need to think about that any longer. Security. Everyone speaks about security. There is a statement that if there is no protocol, no V6 protocol, IPv6, there is no problem, which is incorrect, I think. IPv6 has been activated by default, and the hosts can communicate over IPv6 by default. If you have not updated that, if you have IPv4 support on the firewalls, it proves to be a problem. I remember everyone was talking about wireless some time ago. They didn't want to go wireless because of difficulties and restrictions, but the wireless connectivity was available at that time, and people would just enjoy Wi-Fi connectivity back in the day. The same applies to IPv6. People speak about lots of vulnerabilities in the IPv4, and it seems like that the problems here are the same. In certain cases, the protocol provides new functionality, and the new functionality should be protected. Like, for instance, as I said, people are reluctant to move to IPv6. They just use the IPv4 style, replacing the V4 addresses with V6 addresses. And if your host was unable to get the address of IPv4, they would just use the special prefix instead. Actually, I made it almost on time. And then it's this at this slide I'm showing you the reference links, and please use them for more detail. Just one question to you here: have you enabled IPv6? Have you really enabled IPv6 everywhere, and you've been listening to the presentation that is very familiar to you so far? IS 112 works perfectly, and address translation really works well. IS 112, 624 works well, does not actually require any manual maintenance. It's not a question, but a statement, rather. But I may also ask you a question. Yes, I was quite impressed by the penetration of IPv6 in Switzerland. What did the Swiss really do to get such a high penetration of IPv6? Because we activated in our network IPv6, but people don't even try to use it. They're so reluctant. Neither physical persons nor legal entities. I mean, the large number of users don't even know this term, IP protocol. Seems like that the Swiss people know it. Probably they advertise it on TV in prime time. Maybe that's why. I remember people pointing fingers to each other. Some people don't want to implement it, and some people don't want to use it, accusing each other. Why would we have to use it? We don't have it, but now we do. And it's up to the residential ISPs. It's up to residential ISPs who will be given the IPv6. And Swisscom initiated by default. At home, I have a black box, and it gives me IPv6. As soon as you get this magic black box with IPv6, half of your traffic will be using this recent protocol, because a large number of sites like Google, YouTube, Facebook will be using IPv6, and it will be all over IPv6. Seems like that the large ISPs in Russia need to initiate it. It's them, not the user, not the end user. The small ones have all activated that. Trust Evgenia. She currently lives in Switzerland, so she knows the topic. Evgenia, it's real simple. The speed of implementation of IPv6 depends on the size of the bonus of the managers. The bigger the bonus for managers, the higher the penetration, the better. I'll stay around, so please take it on the sidelines to discuss the bonuses and things. A quick comment. 12 months ago, Cisco had similar statistics, but they split the IPv6 implementation. In Russia, as far as I remember, the backbone implementation of IPv6 accounted for more than 40%. In content, it accounted for more than 30%. For end user, it was 0.29%. 0.29%. That's right, because what we measure is the final result. So it seems like that it's the end users who don't get the settings. If you had come up here 2 years ago, we would have given you IPv6, and we would have activated that without any problems. This topic is quite notorious, but it's just a little bit outside the scope of our discussion. All these problems that you have explained are easier to explain, actually. There was a link to resources, but you did not when we started implementing IPv6, there was no uniform website which would get all these how-tos for newbies. All these principles were not shown on one same page. So bullet point number 1 is actually the book that I was happy to be the editor of. I recommend this book to you, by the way. An excellent book which you can get for free. It's available in Russian. I do recommend all of you to make good use of that. All the truth about IPv6. Thank you very much.